Wow, so many. So that thing over there, is it translating everything I say? Does it do naughty words at all? Nah, no, I shouldn't. Okay, no. Okay, welcome. Okay, so wow, there are a lot of people. This is a lot bigger than the first 101 track over there next to track 4. It's made me kind of nervous, but it's okay. I'll take care of it. So. Okay, so I'm Dennis. Some of you know me, most of you don't. So let's just jump right into it. Are we really safe? Hacking access control systems. So I'm going to talk about a lot about access control systems that matter to you guys. You've seen it. You see it up here. You've seen these in your apartments, your gated communities, everywhere. So let's just dive right in. First, actually, I'm Dennis. I'm a security consultant at KLC Consulting. We do security stuff, right? My job is to hack things. This is one of those things. So you'll hear a lot about what I've done in the past year with my research of this. You can hit me up on Twitter. I love to use the Twitter, especially here at DEF CON. I'm also, for those who are interested, I'm co-founder of Houston Locksport. We're a lock picking club. Hey, there you go. Right? My other co-founders are here with me, Dead and Jay Gore. We just drink beers and pick locks. I was told I was going to get heckled, and I'm getting heckled. So I'm also rebooting AHA. If people are interested, the Houston Area Hackers Anonymous, similar to AHA, Austin Hackers Anonymous, I'll be rebooting that. So if you're interested and you're in the Houston area, come talk to me. All right. So the quick agenda, just real quick, I'll be talking about what physical access control is. Then I'll talk about a specific vendor that I've been doing research on. And the reason why I'll be talking mainly about this one vendor is just because of time and money, right? This thing costs $1,700, and I don't have enough money to buy every single one out there. So I focused on one for now. And then we'll after we talk about how they work and kind of the architecture of them, we'll talk about attacks, local remote. I'll demo some things. We've got a tool that I might release. And then, of course, some device enumeration and some recommendations, because I had to. So let's get started. Physical access control systems. So first, what are they? They're systems with the purpose of limiting access to a specific physical resource, right? They're outside many things that you guys seen. That can be commercial buildings, shared office spaces, so on and so forth. They secure areas by hooking up with doors, whether it be an electro door magnet or door strike or anything. They also use gates for apartment communities, elevator floors, and barrier arms for like parking spaces, right? How do they work? You have many different ways of authenticating to an access control system. A lot of you guys who do live in gated communities or such have a little key fob like this where you press a button and it opens a door. Or maybe it's an RFID reader, or you can go up to this keypad over here and press the button, or whatever you need to do. And so real quick, I'll talk about what this demo is, because I kind of forgot to talk about that. So here I have a linear access controller. It's set up all like how it really would be in a large apartment complex, except there's only one, not 20 of them. What you see is picture frames with lights underneath, 1, 2, 3, 4. Every time you see a picture frame light up, that means door 2 in this case, or door 3 has opened. So imagine that. Unfortunately, you'll never see door 1 open. During my experimentation, I kind of blew up, literally exploded relay 1 that controls door 1. So it's never going to work, just warning you guys. Okay, so moving on, you got swipe cards, you got all these things that you can do to authenticate to these. Where are they used? Again, like I said earlier, they're used in gated communities, parking garages, office buildings, all that stuff. And it's even used in commercial facilities. Walking downtown Austin, I would see it, guarding some, I don't know what it was, a post office or something. So they're pretty much everywhere. You can walk up to them. Here's just a bunch of different vendors I've seen. So there's Door King. You guys may recognize some of these. Chamberlain, Syntex, LiftMaster. I'll go back to Syntex because I kind of too fast, right? LiftMaster and Linear, of course. Now they're calling themselves Nortec Security and Control, but all the boxes still have the word Linear on them. So we'll talk about this one more in a bit. Here's some pictures I took walking around. You've got a bunch of these mounted outside buildings. You can use your RFID card or keypad, whatever you want to do. You've got some outside apartments or outside offices, right? More commercial buildings. These were, I think this one was in a nursing home. You have some next to elevators because they can control elevators. They can authenticate whether someone can be in an elevator and specific floors. And what you see on the right is you see 3 gray boxes. Those are also access control systems, much like this one here, but they're headless. They don't have keypads or screens or anything. They're used for expanding on an existing installation or just installations that only require, for example, RFID readers. Doesn't require a keypad or anything. So that's what those are used for. Here's what they look like inside. Same thing, same components as the one I have here on the table, just without a keyboard, without a big display. This one's actually pretty funny because you see this one's kind of mounted on the wall. You'll never guess where I found this one. Right there. So, I don't know, I wanted to use the bathroom and I was very curious what was inside that gray box. So it may or may not have already been opened, and so I took a peek and voila, access control. It was protecting the doors for that building. That was pretty funny. Okay, so let's talk about linear access control. I showed you this picture earlier. Linear, the vendor Linear, also known as Nortec Security and Control, they have a few different models of commercial access control systems, the AE1000, 2000, and the AM3 Plus. The AM3 Plus is that toilet one I just showed you. But they're all pretty much the same. They're all the same. They all do the same thing. They interface the same way. The only difference is that the 1000 and 2000, it has a bigger screen, right? You see it's much bigger screen. That's the only difference. The AM3, like I said, doesn't have a keyboard or anything, but they all do the same thing. So anything we talk about is going to apply to all of those. So let's go a little deeper into those. So this is a linear controller. It's pretty fancy. It's got a lot of cool features. It's great for big installations because it can be networked. It utilizes a telephone line, so someone can go up there, press a specific directory code. It calls someone else, and they press 9 to let you in. We've all done that. So it can also, it supports thousands of users, so it's great for any big installation. It can be networked with other controllers, so you can, these can only control 4 doors at a time. If you want more doors, you add more to the network of controllers. And the best part is they can be configured and controlled through a PC. It can be networked, so apartment management in a different state can manage all those small communities they have all over the United States. So this is the kit. So these things they're rarely installed just by themselves because they're pretty expensive. Who would want to do it just for their home, right? So they're usually installed in big installations, and to do that, they use this kit, the TCP/IP kit, which is just a device that pretty much turns the serial connection into an IP connection, a TCP connection, and that'll allow the management of the community to actually manage it from a computer, whether it be on the network locally or remotely online. So in that example of a management company at a different state. So let's talk about a little bit of the architecture and how that works. So the controller here, the AE1000 Plus, interfaces through serial and connects through a serial cable to the serial to TCP device. And that pretty much converts the connection into a TCP connection, which is then plugged into a conventional network, a switch or anything like that. And then a management PC anywhere can connect to it. It's pretty much simple as that. This is a typical installation I've seen. And now to refer to that controller, you're just referring to a specific IP and port. In this case, 192.168.0.32, port 4660, which is the default. So here's pretty much the same diagram, except this actually came from the documentation. You have the controller, you have the serial to TCP converter connected to a network, you've got a computer, and of course the documentation actually does encourage that you hook that up to a DMZ or an internet device so that you can actually control this from the internet. So that's pretty cool. Pretty cool for some people. So how does the computer communicate with the controller? They use a software called AccessSpace 2000, developed by the same guys, made just for this. It's pretty thorough software. It allows the management to add and remove users like entry codes or any transmitters like this, anything like that. You can even control the controller You can manually toggle the relays so that you can open the doors remotely. You can lock them so you can keep them closed. You can even view log reports. This controller stores logs every time someone accesses a door it controls or anything like that, or even opens the door right here. The controller, it logs all of this. So that's pretty cool. It's a pretty thorough log. It does communicate through serial, like I said, but again, when you have that TCP converter, like most installations do, then it's a TCP connection in your eyes. And it does require a password to authenticate. So here's the screen of, I hope you guys can see that, it's kind of small, but what you see here is you do need to type in a password to authenticate and use the software to the controller, but it's pretty interesting because the password is just 6 characters exactly. No less, no more, exactly 6, and numbers only. So you can imagine the key space, 1 million passwords exactly, that's it. So may be a problem, let's look into that, but we'll look into that in the attack. So first, how does it communicate, just how does it actually communicate? How does the software communicate with the controller? So first, when someone's using the software on the computer, you have the software sending a string, a hex-encoded string over this connection to the controller, whether it be a string to open a door or request the logs or anything like that. And the controller will respond back with another string, and the string is consistent whether it acknowledged the command and performed the command, or it could be not acknowledged, meaning the command was a bad command, or let's say you tried to open relay 5 and that doesn't exist, you'll get not acknowledged, or invalid checksum. This does utilize a checksum to just ensure data integrity. So if the message is wrong, you get a bad connection or something, it'll spit back invalid checksum, or it'll actually do no response. If you're not authenticated, if you didn't prior put the correct password first, you won't get a response at all. So if you get no response, you're probably not authenticated. So let's break down the message real quick, just so you guys have a background. So this is hex encoded, and it's sent to the controller in hex. So every 2 characters is 1 byte. So the first 2 bytes is going to be the packet header. That's fixed. That's hard coded. The packet header is always going to be 5A, A5. The next 2 bytes is a minimum data length. You'll see highlighted in yellow is the data. And so when you send a command, the minimum length of that data can be 0. The maximum data length is the next byte, and that could be, in this case, 0A. And for those who know hex, that's 10 in decimal. So the length of the data can be 10. Then you have the net node. And so what that is that's just the identification number of the controller relative to any other controllers on the network. So it's 11 in this case. If there was another controller here, that might be another number. There's an algorithm for computing that. Then you have the command. And the command can be different. In this case, this whole string is a password command. It's trying to say, hey, is this the password? So that's 01. There's a bunch of other commands like polling the logs, polling status, doing a flash firmware update. So there's a bunch of different commands from 01 to 0F, right, which is 16 or 15, one of those numbers. And then the next, in this case, it's 5 bytes. You have, actually 6 bytes, excuse me. This is the actual data. So like I said, this is a password request. So what I'm doing is I'm saying, hey, is 1, 2, 3, 4, 5, 6 the password? And that, the data there you see, 36, 35, that is 1, 2, 3, 4, 5, 6 hex encoded and then reversed. For some reason, it wants to reverse the data and then sends it through. So that translates to 1, 2, 3, 4, 5, 6. The last 2 bytes is a checksum. Like I said, it ensures data integrity and makes sure the message is what it's supposed to be. And that checksum is calculated through these from everything from the beginning of the net node to the end of the data. So it calculates a checksum from that, and if it's correct, all systems go. All right. So we've talked about how this works. You guys now have a good understanding. Where am I on time? I'm good on time. Let's talk about attacks. So first, how can we target these controllers? Well, they're meant to be walked up to. They have number pads. They have displays. You walk up to them at a gate or a building, and so you have physical access. What can you do with physical access? Well, maybe we can do local programming, because some of these things can be programmed locally if you don't want to do it to a computer. If you have a much smaller installation, or maybe an older version that doesn't support computer management, you can do local programming. There's also a serial interface inside these devices if you do want to configure it through a computer. So let's talk, since we have physical access, let's talk about local attacks first. So default password. So first, this is the AE1000 right here on this desk. There is an AE500. What that is, it's pretty much similar to these. It's just much smaller. It only supports 2 doors instead of 4. It doesn't allow for computer configuration, no serial interface or anything like that, because it's meant for much smaller installations. It's a lot cheaper. It's meant for 1 or 2 doors or a gate inside a really high-end home. So you have those. Those have a default password. Those can be always programmed locally from the keypad because you can't control it from a computer. So to get to that part where you can start typing the password, you hold 0 and 2, and that'll pop up a password prompt. And in the documentation, all this documentation is available online. The default password is 1234556, and who changes that, right? When you're paying a contractor to install this, the lowest bid contractor, they're most likely not going to care about the password. So they're going to leave it like that. You're not going to notice. And the default password to manage these devices is 1234556, regardless of what your entry code is. So try 123456 and see what happens. Pound is just the enter button. You press pound and see if it works. Once you're in, because trust me, you're going to get in, input the following commands. You have 31, pound 999, pound. You have all that string, and I'll talk about what that is in the next slide. And what that does is that inputs your own backdoor. It inputs your own entry code into the system. So now when you walk up to the device, you type in your new entry code, 9999 in this case, and access grants it. So let's talk about what we just did. So hold on. we've got more. 123456 pound. We've just typed the default password. We're in. 31 pound, that enters the entry code enter mode, right? That's where you enter a new entry mode, program it. Then 9999 pound is our entry code. You can do whatever you want, 1, 2, 3, 4, 5, 6. 9999 is better because no one has that, right? Then you do it again, 9999, just to confirm it because it wants you to do it twice. And then 99 pound exits programming mode, going back to normal functionality. Then you just type in your entry code and you're in. Oops, I forgot I did that. So, boom, that's the summary. So I'm going to show you how quick it is to do that. So all that I just talked about, you'll see how quick it is. So. There you go, and access granted, and that's where the applaud should come in. But and you see, that was done in less than 10 seconds. So I can literally, if I find one of these devices, quickly do my thing, walk off, and now I have full access to whatever that's controlling forever. Because there's no way that I found where you can actually list the entry codes. You just have to, if you're suspicious about it, just, erase everything and start over. So it's really cool hidden backdoor. So what else can we do? Master key. This is going to be interesting. So I bought this, my company bought this for me for research. And of course, it came with a key, right? It turns out, when I found this out, I was flabbergasted to say the least. Same key for every device. This 1000 plus you see here, some of you have probably seen it. This is one of the most common ones I've seen in the United States. When you see this, the key that it came with, right here, I'm holding in my hand, works for this, but also works for all of my other apartments that I may or may not have tried. It works for, so I confirmed that it works for every 1000 where no one has changed the lock, and I've never seen someone change the lock. It also works for the AM3 Plus, the one that I saw I didn't try it on the toilet, but the same one that was on the toilet, it works for that too. It might work for the 8500, never tried it, but why wouldn't it, right? So this same key works for all of them, and you can purchase them on eBay if you're lucky enough. I haven't found one, but if you're lucky enough, you might find one on eBay. You could pay $1,700 and buy this whole thing and get the key, or you can, if you're lucky, the AM3 Plus, the smaller one, find the enclosure alone just for that. It should come with the key. It's $100, and now you've got access. But please don't buy the key. You don't need it. Of course, you can just pick the lock. It's a fairly simple lock for anyone who's decent at lock picking. They can try to pick it, and of course, it gives you full access to the device. So let's talk about that. But first, for those who are into key, making keys, that may or may not be the exact bidding code. So, PowerPoints will be online. Physical access. So what does physical access get you? Well, if you're able to open this device, whether picking the lock or having the master key, or it's just left open, in this device, in this specific AE1000, there is relay latch buttons. So relays are how the doors are controlled. When a relay is triggered, the door is opened. And if something is wrong, like if the software is not working, whatever, maintenance can come up, open it, and press the button to manually open the gate just to leave it open so people aren't locked out. So guess what? There's buttons in there to open all the doors. So let me show you real quick. Test, awesome. So if I were to open this and I don't have an entry code or anything, all I have to do is open it and boom, I'm in, and that's it. And if I were mean and I lock this up, everything stays open because those buttons stay locked open until I either press them again or reboot the device. So that's a cool way of entering if you want to enter with the key. Okay, let's turn those off. There you go. Leave that open for now. So like I said, you can lock their state, so you can leave the gate open and finally have that cool house party that you guys always wanted but didn't want to break the lease. Okay. By the way, I mentioned Relay 1 exploded, literally. If you can see there's a bunch of soot around the capacitors next to Relay 1. That was pretty fun. I had to fan out the house for that. What else does physical access get you? Programming buttons. You get to program the controller. There's programming buttons right there in this one. And other versions, they're located somewhere else. You can program the device, or if you just want to, be a dick, you can erase the memory. Have fun with that. There's an active phone line for those who maybe want to steal the phone line, find out the phone number, and put it back, and maybe you can call it and mess with it or do some pen testing if you want to steal the phone line. And there's also a serial connection, so you can just connect directly to the controller. And all the remote attacks we're going to talk about work either remote on a network or direct serial connection. So you'll figure out soon why you would like serial connection. So last thing is, I just want to mention, there's a tamper monitor switch. There's a little magnet on the corner right there that will detect when the case is open or closed. So in the logs that I talk about, you'll see tamper switch open, tamper switch closed. So that's used so people know, if someone's messing with the device. The problem is there's no active alerts, right? You can connect to the controller, go to a bunch of these buttons, and then you can actually view a log that of someone opening and closing it, but nothing's active. There's no red alert, there's no email notifications. You'll never know it happened until much later when you decide to download the logs and do it. So really, tamper monitoring? There's also a problem. It's magnet, right? So for those who are doing the defuse a bomb competition right next door, that way, you can just use a magnet to bypass this tamper switch. So let's show you how to do that. Let's play. How do I press play? Where is it? Here we go. So I'm opening the controller, and you'll see the screen. It pops up tamper switch open, and then tamper switch closed, as I closed it. And so what I'm going to do is I'm going to grab my big, powerful magnet. It's pretty powerful, so I have to wear gloves. Put it right there where it is. Be careful not to put it in the wrong place. And I open it, and when I open it, you'll see absolutely nothing logs. You'll see the 2 existing log entries from earlier, but nothing new. So tamper switch completely voided. Thank you. Oh yeah. Okay, we're gonna need more of that. Not being sarcastic. Okay, so we've talked about physical access. So what's next? The fun stuff, right? Remote access. Remote access can be done, depending on the configuration, of course, through an internal network. So let's say you're at the leasing office looking for a new apartment, and the leasing agent's busy with someone else, and you plug into the network port behind their desk. So that's an example of internal access. Or guest Wi-Fi network is not segregated properly. Then you also have external access. Some people do have it remotely available on the internet, so that would work too. Everything works over the IP, and usually the default port 4660. It can be changed, but usually who does that? So let's talk about remote attacks. So first, let me show you the software. Let's see if this works. Hopefully I've sacrificed to the demigods. So, okay. So you have the software here. It's pretty nifty. So how you connect is you press this little button and you connect. But you see here, we're getting the message wrong password. I hope you can see that. We're getting wrong password. So we don't have the password to authenticate. So as we mentioned earlier, how can we fix that? Brute force attack. So this is fun because like I told you guys earlier, 6 characters exactly, numbers only, tiny key space, so that's 1 million passwords. There's no rate limiting, so you're only limited by the connection speed, and there's no password lockout, so you can guess as much as you want. And this is scriptable. Since this is, the backbone is all serial, you can just script all this. You don't have to touch the application. So let me show you that. Let's go. So we don't have the password here, but I did write a nice little Python script that may or may not get released that'll do just that. So what you're seeing now is it's brute forcing. It's guessing the common codes, and if it doesn't find it, it will iterate through 1, 2, 3, 4. And so what you're seeing is you're seeing it guess more than once on the same password. That's because I'm having it. If it doesn't get a proper response, whether it's valid or invalid, it just keeps guessing it until it gets a proper response. Serial is kind of, not very reliable, so that's why. And there you go. Master code 000051. It guessed it, it found it, and we're done. So let's go try that. Let's go to setup. Here's how you type in the password. 1, 2, 3, 4, 5, 1. Boom. There you go. I'm connected, no error. Let's go to let's show you what I can do with that. Trigger. There you go. All 3 doors are open. All 4 doors are open. Thank you. Yeah. I'll quickly show you also here if I just downloaded the logs. Let's go to, how do I go to logs again? I forgot. There you go. And just so you guys see, these are all the logs that I just downloaded. Certain people have granted access, locked open, and so on and so forth. So I just wanted to show you guys. So, okay, we'll go back. Brute force attack. So that's cool. What's next? So we have the password now, but did we really need it? Apparently not. So normal way, you have to authenticate first. You submit the right password first before you send any commands, or do you? Right. So what I found out is when I send this device a command without sending it a password first, I wouldn't get a response. But it turns out it'll just run the command anyway. It won't tell me it did it, but it'll just execute it. So I won't get a response, but it'll still work. So any command, most commands work that way. So what can we do with that? Open doors remotely. We can send a simple command to open a door. That's an example of the command that actually opens a specific relay. We send it over, and it processes that command and executes whatever it's supposed to do. Doesn't send me a response, but it still does it, right? So it's still good. And it's great for movie style scenes because, let's say you have the 4 museum robbers, whatever, and the hacker in the van. So when the hacker is ready, the hacker presses something on the computer, the hacks into this, opens the door, the techno music starts, and everyone goes and steals the Declaration of Independence. So it's great for scenes like that, kind of red team engagements. So that's what we can do there. What we can do is we can lock doors open and close. You can send the command to lock the relays just like if I were pressing that button, and that'll keep the doors or gates either open if I want to have that house party, or closed if I want to prevent everyone from ever getting in. And so that will, once the relay is locked in a specific state, it will not respond to any key fobs or any actual legitimate access after that until I unlock it or the device reboots. It persists, it persists until it's rebooted. Another thing you can do is those fancy logs, you can just delete all of them. All those logs are stored on the controller, and because the controller has limited space, whenever they're downloaded using the Access-based 2000 software, they're deleted from the controller. So what do? We initiate a download for those logs with our Python script. We don't get the logs. We don't care because they've all just been deleted, and we've hidden all the evidence of us doing anything. So another thing you can do is if you so want to use the Access-based 2000 software, because it does have some cool functionality, you can change the password. Turns out you can submit a database update, and it'll just like, okay, and it'll change everything, including the password, back to the default or whatever we want, and now we can get in with the default password. So you can pretty much upload anything. You can upload directory codes, transmitters, any backdoor you want, right? So pretty much that. And then the last thing I'd like to talk about is denial of service, which you can, if you want to be a dick about it, you can fake a database update, and when you send it the database update, you don't tell it that you're finished. You just send it the request and go home, and this device will just keep flashing database update in progress. And when a database update is in progress, it locks itself and nothing will happen. No transmitter will work, no entry code, nothing. And the only way to fix that is to stop the database update. There's a command to stop it, or you can just reboot the device. Another thing you can do is you can overwrite the device firmware if you want to brick it. Again, be a dick. You can just break the device and make it completely useless to everyone. Or, like we talked about earlier, you can lock the relays and keep the door shut or something like that, so that no one can get in. So, all those attacks we talked about, what I've done is I've developed a pretty simple to use tool to demonstrate these attacks. So what I call it is, I really couldn't find a good name for it, so I called it Access Control Attack Tool, because I do want to expand on more access control systems, not just this one. But it is pretty neat that I can say, hey, let's go down, you guys can go download a cat off the internet. So let's show off this tool. Let's see if the demo gods have been nice. So I have this Python script. It works on Windows. It works on Linux as well, though some things don't work. You refer to it. You can either refer to it through a serial connection, COM1, through whatever, or IP address. So let's do that. Let's maximize. Okay, so here's my tool. Pretty simple. It's like as point and click as you can get in command line. You just type whatever you want. You have a bunch of options here. And so let's just try trigger relay. So what this does is this will trigger the relay for 2 seconds by default, whatever it's configured to be. And so if I want to open one, well, let's open all of them. 1, 2, 3, 4. There you go. And so this Python script just opened all 4 doors, and no password was sent. Nothing was sent. It was completely unauthenticated. It's just I walked up to my laptop with the script, plugged into the network, found it, and sent it these packets. So relays are now open. Another thing you can do is lock them open. So 3, 4. So now all 4 are locked open. Trust me, 1 is locked. So now those will stay locked until I unlock them or reboot the device. So let's unlock those real quick. 4, 1, 2, 3, 4. Now they work again. Another thing you can do is lock them closed. Oops, wrong. There you go. Lock them closed. So let's lock 2 closed. So 2 is now locked closed, and if I were to try to use the normal transmitter, nothing happens. No one can get in with relay 2 or any of the relays. And so now let's unlock them again. Unlock 2. It's unlocked, and come on. There you go. It works again. So that's a cool thing you can do. So let's show. Okay, so this is the one that sometimes doesn't work, but we'll hope it works. Deleting the lock. So everything we just did, either was a Python script or this transmitter that I'm holding, or even opening and closing that enclosure, it's being logged in the internal memory. So when I download that, I'll get all that, all those logs. So what I'm going to do is I'm going to initiate a download, and what that's going to do is it's going to download the logs, never get them, but they're going to be deleted from the controller. So I've initiated that process. It's working on it. It's trying to see if it's getting any feedback back. And then once it's done, logs have been deleted. So let's exit here and let's see if that works. So I'm going to go here, connect. There you go, connected. And this button is used to download the logs. It'll show a dialog box with the number I'm downloading. If it shows 0, then the demo works. So let's do it. Ooh, 6. So it worked. But what I did notice is when this device has been rebooted, and I did reboot it earlier before the demo started, there are 6 log entries of it starting up that never get deleted for some reason. So just take my word for it that it worked. And maybe we can applaud for that too. But yeah, so if you did look at the log, it's kind of a mess now. You wouldn't see any of this access granted stuff. So let's connect back to my script. So here you go. So we're connected back. The next thing you can do is Let's do upload default configuration. So we're connecting to this with the password of 000051. I'm being attacked, am I? No? Okay. I guess we're good. So we're connecting with the password that we brute forced earlier. So let's go back to the default password. Okay. While they're doing that, what I just did is I uploaded default password to the device. So let's see if that worked. So ideally, if I connect with the existing password, it should fail. Wrong password. There you go. So now let's go back to using default password. 1, 2, 3, 4, 5, 6. And I'm connected. There you go. So just uploaded default password. Who needs to brute force? You guys are so kind. I'm really scared of this. Uh-oh. Hey, how's it going? Oops.
Excuse me.
Okay, have fun.
So, wow, are you giving me your computer? That's awesome.
I'm right here. I am not moving from the spot. Here, press.
So, you want, really? All right, hang on.
Just press that button. I assure you something happened.
Shit. Everybody clear the room. You all know how this works. How is he doing as a new speaker? Are you hungover?
Nope.
You will be.
What is this?
Oh,
No, I want to know. Oh, you're giving me that?
Finest.
Come on, this has got to be better than that. Cheers.
okay. After you drink that, I'll be back with something better.
Oh no. All right.
To DEF CON, to new speakers.
To DEF CON.
You still want that next one? No?
Come at me, bro. Thank you very much. Thank you. Oof. I'm not used to that. I don't do a lot of shots, so it's burning my insides. Speaking of burning my insides, denial of service. Thank you very much. No. I'm gonna ride this out. Okay. So the last thing I want to show that this tool can do, denial of service. So you have the normal functionality. Is that lighting up? No? Yes? No? Okay, I think something just broke right now, but this one still lights up. So normal people are coming up, going in the gate, going home, wanting to watch SpongeBob or whatever, except you denial of service. Controller has been DOS, so I'll take your word for it, but what you should see on this screen is this should show database update in progress. No? No? Not working? No? Let's try it again. Ooh, okay. DOS no longer works. Let's try this. Hold on. I think my controller got drunk. Okay, what this will do is this will flash database update in progress and it would stop working. And then all I have to do is in the same script, you can stop it and then everything's back to normal. So that's pretty much the extent of my tool. I'm going to give it one more try. Trust me, one more. Yep, still doesn't work. Okay, so trust me, it works. And it's really getting hot in here, isn't it? Okay. I'm a new drinker. I'm hungry. Is it normal that I'm hungry? So, now that we've talked about attacking these controllers, and I'm good on time, let's talk about locating these. So how do we find these? Device enumeration technique. So one thing you can do is you can scan for these devices on a network. If they're hooked up to typical installation, scan for them, look for any COM port redirectors, because that's what they are. They're usually default port 4660. There's a specific one that's branded linear that comes with this. Of course, theoretically, anyone would work. So you can scan the network, default port 460. Another thing you can do is you can send a UDP broadcast to UDP port 55954, and if any devices are on the network, it'll respond. So if you look at that little graphic there, an attacker can send a UDP broadcast to the network with that specific UDP port, and any devices will respond back to the network with that broadcast packet and respond back to the person who initiated that broadcast. And so that's how you can identify any of those devices on the network. Another thing, and then once you found it, you can send it a password request string. So regardless of if you've authenticated to it or not, you will get a response back whether a password you try to guess is valid or invalid. So you can send this device a password request string, and if it's a linear box, it will respond back whether it's a valid or invalid password. So that's, again, the same that you saw earlier. That's how it works. You send it something, it responds back. So let's demo yet another tool that a third tool that I wrote just for that. So what this will do is this will send a broadcast packet through UDP and listen for any responses, and it'll find them. If it finds any response, it'll take that step further and send a password request to that IP address it found and check if it's an actual linear controller. So let's do that. So it did find a device. There, let's scroll up. And now it's going to check, make sure it actually is linear. And there you go, linear access controller. It actually detected it is linear. It's 100% confirmed that it's linear. And if you see that asterisk, it also, by the way, confirmed that it's using the default password of 123456. So that's what that tool does, and that may also get released. So, cool. We talked about all the fun stuff. Now we have to go to this stuff. Recommendations. So I'm not really going to talk about how the specific vendor can fix these issues. I'll just talk about how you, as apartment management, for example, can kind of remediate some of these issues. So some of the obvious being always change the default password. Don't use 123456. Use something different. I would love to say use a more complex password, but that just doesn't exist for these devices. So another thing, wow, it's really fighting back. I tell you, I'm a new drinker, and I can't burp for some reason. So, okay, so change physical locks. The master key here works, so change the lock. You have the ability to change it. I see a screwdriver there, so I imagine you can remove it and put a new core in there. So change that lock. You don't want the apartment manager next door having the same access to your apartment as he does to his apartment or her apartment. So change the locks. Another thing you can do to fix, kind of remediate these remote attacks is use a direct serial connection. Instead of having this on a network, if you had a direct serial connection, these vulnerabilities aren't fixed, but you're at least not exposed on a TCP/IP network. So doing that, just would make it a little harder, or a lot harder, for an attacker to attack these controllers. If you do network these devices, utilize authentication. These COM port redirectors, the serial to TCP devices, do allow for authentication. No one ever uses it. It's not pretty intuitive to use, but learn how to use it and utilize that authentication so that not anyone can connect to the IP address of the device. And another thing is, of course, resist the urge to connect this to the internet. Like, don't have it online, just don't forward the port, and just like anything, keep it off the internet unless it really needs to be. So, final thoughts. So I didn't write this talk to crap all over one vendor. I just this is the one I had time and money to invest research in. But I just wanted to open the door and open people's eyes to the fact that if all these issues exist on one vendor, they'll most likely exist on other vendors. So just because you have a Syntex or a Chamberlain doesn't mean you're secure. You could have the exact same issues, maybe in just different ways. So be cautious out there. Hopefully I'll do some more research on this. So I do plan on doing more research on this device and more research on others whenever I can get my hands on those things. So that's ongoing. The tool. So these are prototype tools. More work is needed. As you can tell, one has already failed. But tool is already uploaded. It is located on GitHub. It's open source. Whatever license, I'll put some open source Creative Commons, whatever license to it. It's called a access control attack tool. I do intend on furthering it to do a lot more with this and a lot more with other controllers as well. So feel free to mess with it. Feel free to download it. I need to completely overhaul it to make it more idiomatic, right? So if you guys want to help me with that, that'll be great. It's up there already. I do want to work on an Nmap script to do what my Python script does. I want it to detect devices on the network, and that'll be great for actual red team assessments if the client is using any of these. Maybe even a Metasploit module too, if you guys want. And last but not least, the slides are on SlideShare, so you can download the full version of these slides. They're available. Don't think you'll have to download it from SlideShare to view the videos, but it's all there. So So that's all I have. Any questions?
How do you find the device on the network and the physical location?
And the physical location. So you mean you see it, right? And
Find it on the network, how do you tell where that is, like when, how far?
okay, so most of the time, unless they're configured properly, you won't be able to tell where it is. Now, if that device, if people, upload, hey, this device is named this into the firmware, then you might be able to find it that way, but that's sometimes not the case. Another thing you can do is these COM port redirectors, there's a specific UDP packet that you could send to it, and what that'll do is, if you can see this device somewhere, if you send it that UDP packet, it'll actually beep, so you can locate it. So you can always, I didn't want to talk about it because I don't want to spend too much time, but that's one way you can find it. Other than that, you're pretty much screwed from there. So I have, okay, yes, one more question because I have only 1 minute, then you can talk to me later. So.
What were you doing when you blew up the relay?
Oh, RTFM, read the fucking manual. I was hooking up a little test light, little red light to this, and I didn't read the manual, so I found out that the relay was rated for 30 volts, not 120, so that happened. So anyways, that's all I got. I'm out of time. Any questions, you can hit me up on Twitter at any time, email me, or find me right here at DEF CON. Thank you. Thank you very much.